So basically our equation is now something like n over L minus n, which is equal to C1 e to the kt. I'm just gonna get rid of this. Yeah. So now the best way to continue this is by multiplying L minus n across the other side. So you have n is equal to C1 e kt multiplied by L minus n, which then becomes C1 L e kt minus C1 n e kt e to the power of kt. Now what we need to do is get all the n's to one side so we can factor it out. So that'll be just done by taking this this to the left hand side of the equation. So you get n plus C1 n e to the power of kt, which is equal to C1 L e to the power of kt. And now you can factor the n's out actually, so you can get an n 1 plus C1 e to the power of kt, which is equal to C1 L e to the power of kt. I'm just going to rub a bunch of this out so I can continue solving this. Okay, so we're going to go right up here. So now you have your n is equal to C1 L e to the kt, and you divide both sides by 1 plus C1 e to the kt, so you can get it underneath here. And now you've essentially gotten your final equation, but it has c's, so you probably want to get rid of them using the initial condition right after you rewrite this whole thing. So now if you notice, we're given our initial condition as C1 n 0 is equal to n naught, so we can just go ahead and sub that in over there. So for your n will become n naught, or n0, whatever you want to call it, and then you get your C1 L e to the power of 0 over 1 plus C1 e to the power of 0. This becomes 1, this becomes 1, and you're left with a C1 L over 1 plus C1, which is equal to n naught. Now what you basically have to do is, that looks a lot like a G, so I'm just going to rub that out, and you get a C1. Now we're going to do something similar to what we did over here, where we multiplied the 1 plus C1, because we want to isolate C1. We want to find out what C1 is. So in this case we're going to multiply, get 1 plus C1 to the other side, so you'll get something like C1 L is equal to n naught plus n naught C1, and that is equal to, if you get this to the other side so we can factor it out, you'll get C1 L plus n naught C1, which is equal to n naught. Take this out and you get L plus n naught is equal to n naught, and you're left with the C1 is equal to another G. C1 is equal to n naught over L plus n naught. Wow, so that's your C1, and you can go ahead and sub that into your equation over here. Now it does look really complicated, so the best bet would be to, I'm just going to go ahead and erase all this. Our best bet would be to actually do something they did in the solutions, which I didn't do, but it's a good idea, is divide everything by C1 e to the kt basically. So you get something like L on top and C1, 1 over C1, e to the kt, negative, because it's dividing, plus 1. So that really makes your equation slightly easier. And since it's 1 over C1, so when we actually sub that in over there, you're going to get an L over L plus n naught all over n naught e to the kt plus 1. And what you can do now is go ahead and basically get the n naught out of there, divide everything by n naught, so you end up getting this out of here, and you have a bracket, and you get your n naught up here, and your 1 becomes an n naught right here. So now that you have that equation, this is basically your final equation. And the reason I actually divided everything by c1 e to the power of kt is because substituting this into two equations over here could be a pain in the butt. So it's much easier to just substitute it once rather than twice. So now that you have this final equation, you can just go ahead and look at the condition they want. So they want us to check if, as n approaches n of t approaches n of t approaches L, t should become well, as t approaches infinity, n of t should equal L. So this whole equation should be L. So if we go ahead and do that, you'll find out that using any graphical calculator, L minus n naught plus n naught e to the power of negative infinity t, negative infinity plus n naught. This whole equation will actually become 0 because e to the power of a negative, well, over a very huge number, it will be 0. And in turn, this whole equation will become 0. And you're just left with an L n naught over n naught, and your n naughts can cancel out, and you're left with an L. So that's basically how you can, let me just write limit as t approaches infinity. So that's basically how you prove it. You can check this with your any calculator or a Wolfram Alpha or whatever you use to check, but e to the power of anything that's really big in negative terms will give you 0. So that's your final answer for question 1, part B, assignment 1.